Howdy folks, welcome back to another CS 120 honors lecture. In today's video, we're going to be covering pattern matching in Rust. So the goal for today is to introduce match statements above all things. So we'll briefly go over strings, then go super in-depth into match statements, and then talk about how you can sort of manage your control flow within your program with a match statement. This is a one-off lecture on a Wednesday. We usually only have lectures Tuesdays and Thursdays. It's just that the lecture tomorrow usually runs long based on prior semesters. So we're splitting this off into a separate lecture that will just introduce match. Tomorrow's lecture will introduce enums, and we'll talk about how to match enums in tomorrow's lecture. So hopefully this one doesn't run too long, but there is just so much to cover when it comes to pattern matching in Rust. Okay, so I'm going to briefly go over some announcements and then talk about strings, and then the bulk will be on match statements. So homework one released yesterday. It's due on the 7th at midnight. It is due a week later, so the 14th at midnight for 70% credit. All assignments are due a week later for 70% credit, so just keep that in mind. MP0 released an hour ago, actually, and it will be due at midnight on the 15th. All homeworks and MPs and all Prayer Learn assignments will have a question called feedback survey. So you can ask anything, say anything, give us feedback, ask about some questions or problems on the homework, ask about some lecture topic. We'll be periodically checking those if you have anything to ask. Please do comment on Discord if you if you have a question that is applicable and you think many other students would like to hear, but you also have the feedback survey to sort of keep yourself anonymous from other students. Okay, so I'm going to quickly talk about strings. So there are two types of strings in Rust that we will be working with. There are many more different types. These are the two that we'll be covering in this course. So there's the &str, also called a string slice. That'll be more apparent why it's called a string slice in a future lecture, but &str is called a string slice, and there's the capital S string type, which is a struct. Again, more on structs later, but these are the two types of strings you'll see. We'll have a dedicated lecture onto why there's a difference once we cover Rust's memory management mechanism, but I just sort of want to give you an interface that you can use, some functions you can call, how to convert between them, but you'll get a more detailed understanding as to why there's these two types in the future. So generally, you can modify or add to a variable of type string in place, so you can just mutate that variable directly, but you cannot when it is of type &str. You'll have to create a new variable and sort of make that modification to the new variable if it's an &str. Both functions have methods to both types have functions to parse, trim, extract characters, extract substrings, split, etc. You can find all of those functions in the documentation. Just Google that, Google &str docs or string docs for Rust. You might see capital S string. You can think of this as a pointer to a string, but again, more on this next week when Arul is covering ownership and borrowing. Okay. So to create strings, creating an &str is very simple. You just type out the string you want, surrounded by double quotes. So if I want the string CS128 honors, I should create a variable, let y equals, and then in quotes, CS128 honors. If you try to copy directly from the slides, just be wary that the quotation marks that are on the slideshow are not accurate. You'll have to use the sort of native double quotes feature. I don't know why slides autocorrects that. Anyways, you also have the capital S string. You can create this by either string : from, and then the string you want inside double quotes as a parameter, or you take an &str, so the double quotes surrounding your string, dot to string. And if you wanted an empty string, something you're sort of adding to throughout your program, you can use string : new, and then I'll create an empty string for you. To convert variables or values of some numeric types and a few others, you can use the .toString method. So .toString, if it's available, will convert whatever type to a string. So 5.toString, or you have some variable x.toString gives you x as a string. Or, sorry, rather 3.1415 as a string. Okay. To convert between them, &str to string, use the .as_str method. We'll be using this in an example later in the lecture. But to convert from, or sorry, this is a typo, from string to &str. I'll have to fix that. As str. There are a couple more ways to convert from string to &str. You'll learn more about this later. Again, this should be flipped. From &str to string, you use string from, and again, .toString. Okay, so I also want to talk about format strings. You'll see these in the lecture. You can use the format macro. I say macro and not function because it can take a variable number of arguments, and I want you to notice this little exclamation mark. You need that. And this format macro composes capital S strings from a bunch of other values. So as a quick example, we can say format, and then we have this &str, which has these curly braces in the middle. So what's going to happen is this is going to create a string that fills in arg1 here. You can put whatever variable, whatever value you want here, and it will fill arg2 into here. So the result will be a string that has arg1 and arg2 formatted into the string in chronological order. So use curly braces in the format string to specify where you want to place the arguments. Arguments are placed in chronological order by default. There are ways around this. There are more sort of details to formatting, more nuances. You can read all about those at this link down here. But again, that is beyond the scope of this lecture, just something you should keep in mind as you see the examples. All right. Okay, so on to the match keyword. So matching allows you to sort of compare a single value against a series of patterns. And we'll show you what patterns are. And then you get to execute some code based on which pattern that the value matches. And so each sort of pattern that you're matching, it has some associated code that you execute with it. Each of these cases is called an arm in your match statement. So a match is composed of multiple arms. And then patterns can be made up of pretty much anything. Literals, so numbers, decimals, &str strings. It can be made up of a variable name, of wildcards. We'll show what this means in the examples down the road, and in tomorrow's lecture on enums. You might be familiar with a similar construct, the switch statement. I'm sure you've seen that in Java, perhaps Python. Match is a switch statement on steroids. So I also want to point out match statements are an expression, which means they can evaluate to a value. So we can assign the result of a match statement to some variable. And so you'll see some examples in this lecture where we're assigning the result of a match statement to a variable. Sometimes we're not doing that. It can go either way, so keep an eye out for that. Okay, on to the first example. So we have this function get course number. Let's assume it just gives us some integer, and we're going to match this variable course. We're going to see what pattern does it follow. So the patterns for an integer are quite literally every single integer possible. So perhaps our integer is 124, and we'll say the professor is Professor Town. Or 128, we have Professor Nowak. 173, Professor Fleck, so on and so forth. I want you to notice that there's a pattern on the left side, followed by this little arrow notation, and then a value or an expression on the right side. And so match statements are a comma-separated list of these arms. So I said match statements have to be exhaustive. So you'll notice this statement here covers the rest of our cases because there are, a large number of integers, and we don't want to enumerate all of them within this match statement. More on the next slide. Okay, and in this example, we have a capital S string that is the result of this getRandomCall. Strings are not patterns, believe it or not. Only &strs are patterns. So on the left side, we have this ILL pattern. It is an &str. You cannot match strings unless you convert them to &str. That's one thing I want to point out. Okay. Let me hide my camera. So an &str is a pattern, strings are not, so you have to use a conversion method to get an &str from a string. Okay. Some rules about matching. So like I said, patterns you try to match must be exhaustive. So if you have something like an integer, you must match all integers possible. If you have a string, you must match all strings possible. This can be a lot. There's an infinite number of strings. There are many, many, many integers, depending on the type of integer you have. So your match arms must cover all possibilities, and that can be quite painful if you're going to type out all of those. So luckily there are some ways around that. You saw that in the example. So match arms are a comma-separated list where each arm is composed as follows. Like I said, it's a pattern on the left with the arrow notation followed by the expression on the right. So expressions are any piece of code that evaluate to some value. So they can quite literally be a value. It can be some other statement like an if statement, a for loop, anything that yields a value. Right, so it can be some type of code within curly braces, another match statement, so on and so forth. So if you have match arms that evaluate to some type, so if your arm evaluates to a number or a string, all other arms must evaluate to that same type. There is an exception. If you return immediately from the current function you're in, you do not have to evaluate to that type, but all arms have to evaluate to the same type if they are not returning. Okay. So we said that our match statements have to be exhaustive, and we want a way to avoid typing out every single possible value that we're trying to match. So for that, we can use what's known as a wildcard. So the wildcard is the underscore symbol. You probably noticed that in the very first example. We use an underscore to match all of the remaining possibilities that are not covered by the patterns that we've already listed. And so when we say wildcard, we're sort of telling Rust that we don't care about what value is matched. We just want to sort of take care of the default case. We've listed all the cases we do care about, and with this wildcard, we don't particularly care about what that value is. So this will come up and be handy in tomorrow's lecture in enums. So it is very, very general purpose. Okay, so back to that first example, we have these 4 cases that we do care about, and they each yield a value, and we have this underscore, a wildcard, to indicate that we don't care about the remaining values. And again, there's an infinite number of strings. We care about only 4 of them, and then the remaining we don't care about, so we can ignore. Okay, let's go to a brief demo. So in here we have course. It gets us a number, and we're trying to match course and bind the result of this match statement to a variable, then print that variable out. So here we're returning 128 from the function. So our match enters the second arm. We get Professor Nowak. So we're printing out Professor Nowak teaches CS128. If we change this to, say, 374, that is not covered by one of our match arms. And so we'll enter this wildcard case, and it'll print out, I don't know who teaches CS374. There we go. Okay, onto the string case. We have this get random call, so we're going to get a string, Marco. We can't match capital S strings, so we have to convert that to an ampersand str with this as str method. So let's run that. So if our call is Marco, we'll get Polo as the response. All right. So this is the more advanced features of match. There's a lot of funky syntax, so bear with me. There are lots of examples. You can find these examples and all the code on GitHub. It's linked below. So yeah, don't worry too much about memorizing all the syntax. Just refer back to these slides, refer to the Rust textbook. Yeah, with that, here we go. So if the type we're trying to match can be decomposed, so think like a tuple, we can choose to match all or some specific parts of the type. So if it's a tuple, we can choose to match maybe the first element, maybe the first two elements, maybe the last two. We can match a specific part of that tuple. This also applies to structs and enums, but more on those in future lectures. So we use the wildcard, the underscore symbol, to indicate that we don't care about matching a specific part of the data type. We don't care what is in that location of the data type. We only care about the other expressions we've asked to match. We can use the range notation, so 2 periods, to indicate we don't care about matching the portion that the range covers in the data type. So say you only care about the first value in your tuple, you can simply specify the first value that you're trying to match, and then use 2 dots to specify that you don't care about what happens or what appears in the tuple. You only want to care about the first value. Okay. And so we can bind values in the match statement to variables when we want to continue using the match value. So these act similar to the wildcard, except we're indicating that we do care about that particular part of the data type, and we want to bind it to a variable that we can use in the future. So variables act just like the wildcard. They cover the remaining patterns, but we can then go on to use the value bound to the variable in some code snippet. So let's go through each sort of arm. So we're trying to match some triple, a tuple of 3 integers. The very first case is, the basic. You have a triple that is 1, 2, and 3. These are all literals. This is a pattern. And so if we see 1, 2, 3 as our triple, we can just print got 1, 2, 3. Okay. So this is where we're using the first wildcard. This is saying we have a triple, but we don't care what happens in this this first sort of slot in our triple. So we already know we haven't matched 1, 2, 3 because we evaluate matches from top to bottom. So this is not a 1, but it can be any other number. And as long as the next 2 numbers are 2 and 3, we'll hit this case. So if we see some other number here, we can print ends in 2 and 3. The same thing applies. We can put our wildcard anywhere in our triple. So if our wildcard is in the middle, and we have 42 on either side, that's the meaning of life. If we have 199, 128, and we have any other value down at the end, we got CS128 honors. So you can put your wildcard wherever you don't care about matching a specific value or pattern. Okay, so here is the range notation. So we're matching a triple, which means this has 3 elements, but we only care about the very first one. So we are only looking for 128 in the first position. There can be any 2 values in the final two positions in our tuple. Likewise, we don't care about the first two values here. We only care that the last value is 2002. And if it is, we can print out this. Okay, so this is what I was talking about variable binding. A is not a pattern. There's no quotes. There's no sort of identifiers. A is quite literally a variable. So if we see a tuple that has 1 and 1 at the end, that will match this case. AX is a wildcard here. So if we ever see a tuple that fits this pattern, anything in the first slot, 1 and 1, in the next two slots, will hit this match case. So we got, and it'll sort of print whatever A is and 2 1s. And if every single one of these patterns fails, we'll hit this last case. This acts as our wildcard. It will match every other pattern that is not previously matched, because variables act as wildcards, but we end up getting to use those variables in whatever expression. So if none of these patterns match, whatever the first value is, it'll get bound to X, second value will get bound to Y, third to Z, and we'll print out that sum. So this will be very handy in your MP. You'll be doing this sort of triple destructuring on enums, so stay tuned for that in tomorrow's lecture. Okay, some more sort of funky syntax. You can match a range of values using this dot dot equals notation. So whatever range is between value 1 and value 2, you'll get an inclusive range match. I'll show you that in the next example. You can use a vertical bar, the bitwise or to match any patterns that are separated by the bar, and you can execute the same expression for each pattern. Again, more in the next example. You can use the variable at expression syntax to bind a variable to some range of values. So say you have this range notation or the bar notation, you can bind that to a variable. So if we have a range, we can say num will get bound to whatever number that gets matched to this range. So if whatever we're matching is between 0 and 100 inclusive, we'll bind that to num, and we can use num in whatever expression happens after. You might need to use parentheses if you're using something like the bar symbol. So if we match 2, 3, 5, or 7, we'll bind that to the variable small prime, and we'll get to use small prime in whatever expression happens after. Okay. So again, this is a very, very dense example. We'll go through all of them arm by arm. So what I want you to notice is this match statement, the result is getting bound to the variable MSG, which is a string. So all arms have to evaluate to a string. So that's the first thing. Next is notice the format string. We'll be using variables in our format strings. So these return strings. Go back to the previous slides in the lecture to see how format strings work. Okay, on to the arms. So if we see a value between 0 and 99 inclusive, we'll just say invalid number as a string. If we see either 128, 225, or 341, we'll say that teaches C or C++. Again, another range. And then if we have, actually this should be deleted. If we have a level, or rather if we have some value between 100 and 399, that will get bound to level. And then we can sort of extract the hundreds digit from that and just print out blank level course. If we have some number between 400 and 499, we can sort of evaluate an if statement. So if the number is 461, say my favorite class, otherwise it's just some other upper level elective. And again, another range. And then at the end, we have a variable, which acts just like a wildcard. Whatever value will be that we have not yet matched that hits this case will be bound to n. We can say CS blank is not a valid course. All right, that's all, folks. That was a very dense lecture. Refer to the slides for these code examples. You'll be using these in the first few homeworks. We'll sort of be reinforcing how to use match statements. Some ranged match statements can be very, very handy in a couple of the problems we give you. So yeah, refer to the slides. They're linked below. They're linked on the website. And yeah, good luck. Take care.